Alrighty, so we're going to start only 5 minutes behind schedule, and hopefully I will be able to catch up a bit. I'm very happy to welcome you all to this Eclipse IoT Day. I'm Benjamin Cabé. I'm with the Eclipse Foundation. I will be your host today, and I'm also kicking off the day with some introduction about Eclipse IoT, what we do in our community. I think I don't need to introduce the Eclipse Foundation. I would hope that many of you guys were just next door to hear Mike tell you about what we do at the foundation. He mentioned IoT a couple times, so I will basically tell you more about what we do, and throughout the day there will be lots of talks, lots of feedback from the trenches, if you will, from people, from companies who actually build on top of Eclipse IoT technology. So just to make sure, I guess especially since we are in the Silicon Valley, when I think IoT, I don't think necessarily like cool gadgets, consumer gadgets that like are going to allow you to, like you're going to put some sensor, some GPS sensor somewhere on your dog just to track where the dog goes. Yeah, that's fine. But I would hope that IoT starts more with like real industrial actually use cases in mind. And it's all going to be about collecting the data, right? You're thinking about an application and what's going to help you build this application, collect all this data. Well, that's going to be IoT, right? You're going to have to put some sensors, actuators somewhere on physical things, and by means of a whole bunch of technologies. Some of them might actually be existing technology. Some of them are new and maybe dedicated to IoT use cases. You're going to be able to bridge the physical world to your backend systems where all the data is going to come in, right? So that would be the typical architecture for an IoT solution. That's like super simplified, I guess, but three main pieces, three main components of any IoT solution in my opinion. You would go all the way from the sensors that I just mentioned, so constrained devices, like very, very small microcontroller units where it's very likely that you will need to make some choices in terms of what protocols you want to support, what you will want to put in there in terms of logic. A gateway is going to probably allow you to bridge the actual sensor to the internet by means of like that's a good old internet gateway, if you will, taking some existing industrial legacy protocol on the sensor on the constrained device side and pushing the data, the telemetry data, actually to some backend system, as well as allowing for commands to be sent to the field to update the devices, to send new instructions, new commands. And then, of course, like you have the cloud, the backend system where the data is going to come in, where you're going to also want to manage your devices from, right? From your backend system, you want to be able not only to create your end user applications, but also to operate your fleet of IoT equipment, of gateways, devices, etc. So I won't like go into detail into the specific characteristics of each stack, especially since you're going to hear about it more today. But devices, think really constrained, small. You probably have also a cost concern in mind. This is where the billion of devices are going to be, right? The billion of things of the IoT that's here. So if you can save a quarter of a cent by getting rid of some memory or getting rid of support for such or such protocol, you're going to do it. So that's going to be really a very, very specific problem that you're trying to solve on the constrained device, on the sensor side. At the gateway level, this is all about connectivity, providing the connectivity, the ability to turn your events, like your real-time physical events, into actual messages that, by means of the gateway, you're going to be able to feed into your backend system. And there, in a nutshell, the concerns would be around making sure that it's going to scale, and scale not only in terms of the amount of data, the quantity of data, but also the variety, right? Your backend system is going to be very different if you're thinking industrial automation use case if you're thinking home automation use case, and yet the data is probably going to end up in some kind of like you want the data to end up in somewhere where it can be accessed consistently, right? So at Eclipse, our vision is that for those three components, you basically need 3 software stacks, right? On the constrained device, you need everything to allow you to have some embedded software that's going to be portable enough so as it won't be that big of a deal if you want to switch from ARM to MIPS sometime during your development cycle. On the gateway, it's more going to be about supporting as many protocols as possible to make your bridging between the physical world and the cloud world as flexible as possible. Have some kind of rules processing maybe at the edge, data analytics at the edge as well. And on the cloud backend, this is about being able to ingest the data, and again, the quantity and the variety of data is quite an important topic for IoT. The ability to manage your device fleet, that's also something you really need to keep in mind. If you cannot operate and upgrade your devices, you're not really in control of your solution. Think security issues or just like the ability to upgrade the software. And there's some cross-layer concerns, if you will, like security. You need security all over, right? You need, ideally, you need some kind of ontologies or ways to be able to describe what's the actual semantics of the data. Finding somewhere in a data store a temperature value that says 70, well, is it Fahrenheit or Celsius? Is there a way to basically describe this and make sure that you don't lose information over time? Tools and SDK, what kind of support can you get in terms of IDEs and the like to develop your IoT solution? So that's kind of the vision in terms of software stacks. And again, you're going to learn a lot today about what those stacks are. What's important for an IoT ecosystem to be successful is that those stacks are open. And by open, I mean not only and ideally based on open source, but open as in interoperable by construction, if you will. If you build your IoT solution and your IoT software stacks on top of open standards, then of course that helps. You're going to have interoperable communication protocols, right, such as MQTT, lightweight M2M. That's going to help. If you have APIs for at the gateway level, at the cloud level, then that's going to make it easier for a gateway from vendor A to talk to a cloud from vendor B, and maybe to a cloud from vendor C further down the road. Modularity within each stack, the ability to replace some, some security implementation in the device by some hardware module that's going to take care of the security and interchangeably replace some modules, right? The independence to the platform as well, especially on the cloud. Some people will be interested in running an IoT data store on top of OpenShift. Some others might be interested in running it on top of pure Docker containers, and that needs to be supported by the solution, right? So that's what we do at Eclipse IoT. I will be spending a few minutes talking actually about the technology even more. And then I also want to tell you guys about what we do beyond just enabling people to collaborate on effectively developing the software. So we really are a community of open source projects, as well as companies, individuals who collaborate in an open fashion to make IoT possible, right? So what are the use cases? What are how the open source projects from Eclipse and maybe from elsewhere can be used in combination with open source, and commercial solutions to build and to solve real world problems. So those are our, to date we have 32 members, so that goes all the way from integrators to hardware manufacturers to service providers. So you would find, many of those companies are actually here today, right? You're going to hear from Bosch about how they are doing software rollouts for IoT. You're going to hear from Red Hat on how they are doing and building a scalable cloud infrastructure for IoT, and how does Samsung create the bridge between open source software and their hardware solution? How do they support the open source community in that way? So a few charts about what we do technology-wise, and lots of project name dropping, I guess, and you'll hear about them more today. For those who've been following, so like Mike said just earlier, 5 years ago, we were essentially just getting started, and we started with a collection of open source, we call them building blocks, right? Solving a very particular problem. How do you do MQTT communications? Well, Eclipse PAHO is a project that provides you with the protocol stack. How do you do lightweight M2M? How do you do CoAP, et cetera, et cetera? So that's fine, right? That's how open source works anywhere. Really, you get projects that solve a particular need, but at some point you need more. You need some more integrated stack. When you want to build a gateway, you might require 10, 12 different open source projects. How do you consume them in a way that it essentially just works and you put them on your Raspberry Pi or on your industrial grade gateway? So that's where we're headed, right? At the device level, at the constrained device level, our vision for an IoT stack there would be that for the hardware abstraction, you can rely on Eclipse Edge. And Jérôme from MicroEJ will have a presentation later today. That's essentially Android for IoT. That's kind of like much of a simplification there, but yeah, essentially Java APIs, Java abstraction for your hardware APIs. You can use PAHO for doing MQTT. For device management, you can rely on Eclipse Wakama, which is a lightweight M2M implementation, and Joaquin Prado from OMA will tell you about what lightweight M2M is, but essentially that's a super small, lightweight stack for doing device management. How do you do firmware upgrade over the air in a standard fashion across all your devices? Well, by means of lightweight M2M. At the gateway level, there's, depending on what kind of gateway you want to build, more of an industrial gateway, a home automation gateway, a more general purpose kind of gateway, there are several stacks available at Eclipse. One is Eclipse Cura, and there's actually several presentations today about it. Think about a Java environment, an application container for your IoT applications, where built-in is a bunch of industrial protocols, Modbus, CAN bus, serial, you name it, OPC UA, so, and an application container. So basically, you're going to be able to create apps, plugins, call them however you want, so as in a car, in a shop floor, you will have a gateway that will talk to many sensors, collect the data, and turn that into actual meaningful data being pushed back to a backend system. Eclipse Smart Home is everything smart home. So all the protocols you need, and you know that there's just so many of them, right? Every home automation vendor is creating their own silo, but by means of Eclipse Smart Home, you basically bridge them all, and you have one single solution to have a rules engine, a UI, a text-to-speech engine, speech-to-text, you name it, for everything home automation. And Eclipse Smart Home is actually being used by companies such as Deutsche Telekom, and they are actually the main contributor. They built a complete commercial home automation solution in Germany called KiwiCon, right? And on the Cura front, by the way, there's also vendors such as YourTech who are building commercial and industrial-grade gateways that do support Eclipse Cura. On the cloud, many components available there. Building blocks wise, if you were to think like feature by feature, if you're interested in device management, you can certainly look at Eclipse Leshen. That's a Java implementation of a device management stack for lightweight M2M. Eclipse Hogbit, and you'll have a presentation from Michael later on about Eclipse Hogbit, and actually have some more charts about Hogbit later on. That's a very complete solution for software rollouts. How do you manage an upgrade campaign for your millions of IoT devices? How do you make sure that you don't kill the network by asking all the devices to download a gigabyte worth of firmware all at the same time? How do you make sure that it's more of a seamless process? That's what Hogbit does, and that's a project from Bosch, mainly originating from Bosch. If you guys are familiar with MQTT in any way, you know Eclipse Mosquito already. That's a very popular open source broker for MQTT communications. And that's building blocks, right? How do you integrate this into more of a platform? Well, this is where Kapua comes in. Kapua is a microservice-oriented architecture, if you will, for IoT. So that's Kapua is meant to host all the microservices you would require for IoT. You require a data store, you require some identity management service, etc., etc. So Kapua provides all that, and over time we expect building blocks such as Leshan or Hogbit to effectively become microservices that live within Kapua, and all of them would be accessible with a single consistent set of APIs, a single consistent UI. So that's Kapua, and companies behind Kapua would be the likes of Red Hat, Eurotech again, and those companies are working really hard on making sure that Kapua works well in cloud native environments, if you will, on OpenShift or environments such as Cloud Foundry, and of course, well, Docker as well. Speaking of cross-layer concerns, so very, very quickly, security, ontologies, and tools. Security, we have a bunch of projects around it. Eclipse KT is actually a very interesting one. How do you take OAuth to the next level for IoT? So that is, how do you get to a point where the granularity of your access rights and access control rules for things, devices, equipment, data is granular enough, so as you can make sure that only people that are supposed to access devices or data have access to the devices or the data, right? So that's Eclipse KT, and there's a talk later on today. On the ontology front, a very popular project is Eclipse Vorto. So it's all about describing the capabilities of devices, sensors, and use those models to basically do things such as, well, code generation, to say maybe a naughty word to some, but that's actually very powerful. If you start thinking, okay, I'm going to model all the capabilities of my temperature sensors, etc., things like providing data conversion or creating like the scaffolding of a UI or of a mobile app by means of generating most of the code, that's actually quite interesting. And what's also very interesting is that Vorto comes with an online repository of all the models and all the code generators. So as a solution developer, you can basically discover, okay, I have this sensor from TI or from Bosch. Let's get the model, let's load it in my IDE, and let's use this or that code generator to do something meaningful. On the tooling front, we could certainly use more in terms of tooling at Eclipse in particular, but we have a bunch of fairly interesting tools within the Eclipse PAHO project. So for MQTT, we have MQTT Spy, which is a very cool UI for monitoring MQTT data streams and doing simulation even. IDE, of course, Eclipse as a very strong history and expertise in making IDEs. So the Eclipse CDT environment for any C or C++ developer is like, I think is very well suited for developing for your constrained devices and whatnot. Eclipse JGT for Java, or Eclipse Che, which is an environment in the cloud, and I think you will hear about it a bit more from Samsung today. Also allows you to develop IoT solution, and there's, for example, there's support from like Samsung is providing an IDE based on Eclipse Che for their Arctic devices. Eclipse Titan for people interested in like doing large-scale validation of communication scenarios for IoT protocols. Eclipse Titan is actually an implementation of the TTCN3 standard, and companies such as Ericsson are using it to validate protocols such as 1M, 2M, or MQTT or CoAP, if those names sound familiar. So that's the technology. Back to the how it looks like in terms of stack. That sounds familiar, and just to show you that hopefully we have your back covered pretty much everywhere. That's how some of the projects I already mentioned map to the functional blocks, and some of the projects actually I didn't even mention. There's just so many, right? There's 30 plus projects. If you go to iot.eclipse.org website, you'll hear about them some more today as well. And yeah, trying to catch up on the timing, but I need just a few more minutes to tell you guys about what we do beyond just the code, right? So code-wise, we certainly do a lot over the past five years. Started somewhere in 2011 we accumulated more than, so I actually lost track. It's somewhere between 28 and 32. We have some projects in the pipe, including very cool stuff around digital twin, by the way. A project called Eclipse Ditto, check it out. So that's probably making it 29 something. Lots of code, many developers, either committers that like work on the projects virtually on a day-to-day basis, or people who just contribute bug fixes, new features, etc. That's really a lot of activity. Lots of also traffic on our web properties. So we do lots of marketing actually and education around IoT. So that's what we do beyond just the code. And there's lots of companies who are actually adopting Eclipse IoT today, right? And just to name one, and that's just like making a random decision there, but that's a very, I actually mentioned other companies earlier, right? And what Deutsche Telekom is doing with smart home, etc. But just last week, Bosch Connected World, the Bosch show in Berlin. This is Todd. He's from Bosch Software Innovation, and he's basically presenting the IoT suite from Bosch. And so that's really way too small for you guys to see. You may see, hopefully, the Eclipse IoT logo over here, but this is all the components of the Bosch IoT suite. They have something they call the IoT Hub. So that's data ingestion for IoT, scalable data ingestion. Well, guess what? That's based on Eclipse Hono. That was on the slide earlier. They have a solution for software rollouts. It's called rollouts. Guess what? It's based on Eclipse Hogbit, right? And it's not just them. There's lots of companies who are actually building either their cloud infrastructure or their gateway infrastructure on Eclipse IoT technology, right? And so at Eclipse, we're trying to do our best to educate people and, well, historically, I guess, developers, right? We also, we have like a very large developer audience. So we educate people by means of things such as our virtual IoT meetup. Every other week, we invite IoT experts to share their vision on IoT and tell us more about the technology they're building, be it on Eclipse IoT or not, by the way. The Open IoT Challenge, Mike, I'm sure you were as excited as I am, and he was, about the winner of the Open IoT Challenge this year. They are fighting a mental illness by means of IoT and open source technology using Eclipse Vertex, Eclipse Cura, and some. And then getting more maybe into the value we provide also to our members, right? We have like Eclipse IoT is projects and is also a working group. And what the working group is doing, among other things, is also providing a marketplace for people to, like, if you go to marketplace.eclipse.org, there's actually already a lot of plugins, components that you can get, just like you would get them from your Apple Store or your Google Play Store. And plugins that you could get and install in your Eclipse Smart Home environment or Eclipse Cura environment, right? And over time, we expect also to list more services over there, not just necessarily software, and allow people to showcase their expertise on Eclipse IoT stuff via the Eclipse Marketplace. And last but not least, Eclipse Testbeds. How do we, like, open source technology is nice, but what is even better is trying to solve real business cases with the technology. So we are putting together test beds where essentially what we want to do is make sure that the projects are shown in the context of a real end-to-end solution, such as asset tracking. How do you make sure that a parcel is delivered to its to the right person and is not being damaged in any way? That by putting vibration sensors, temperature sensors, and whatnot. How do you manage the parcel from point A to point B? Well, we are putting up a test bed together with Red Hat, Eurotech, and others, where there will be like actual sensors, actual gateways, actual backend systems, and there will be open source, and we'll tell you how it fits into like the overall architecture. And there will also be an ecosystem of vendors and commercial solutions around it, right? So that's a strong focus for us in the next few months as well. So that's what I had, and I'm pretty much sure I didn't manage to catch up on the timing, but still, I think I'm still in the 25 minutes time frame, and I probably have 0 minutes for questions. This is our website. So throughout the day, you'll hear about Red Hat, you'll hear about Samsung, careful this afternoon. If you're looking at the printed program, I think it's off by something like 10 minutes. So we'll correct that later on today. But my guess and my hope is that many of you guys will basically just stay in the room all day. I think we have a break later on in the morning. I will be looking forward to speaking with you all. If you want to find me later on today, I'd be happy to answer any questions you may have. Enjoy your day, and that's what I had for you guys. Thank you.